Hello, welcome to this short video here. We're going to talk through CAD Simulations Airbus A320 family FCU custom LCD. So if you haven't already ordered one of these and you're just coming across this video by chance, then this is a LCD for which you can insert into your home cockpit build for flight simulation. It's compatible with MobiFlight, or you can use it on its own if you want to program it into an existing system. You can find out more about it by looking at the website there, but this video is really going to get into a quick setup for once you've received your device, how to just get up and running with it as quickly as possible. So what I do want to talk through is that there is some GitHub documentation here, which is freely available, everything on here. We're just going to go into the FCU because the EFIS has not yet been released. So there's a data sheet here which we'll quickly look at, which goes through and details everything you need to know you could possibly think about for this device here, but we're not going to go through that right now, but it is there for you. What I want to do is go through these three files here. First one is FCU test, which is what we're going to do today. Libraries are the raw libraries for the device to interact with, but we're going to touch on that a little bit later. But if you just want to get up and running, you know what you're doing, there they are. And then there's the MobiFlight plugin, which I'll probably do a separate video on. But that's really just to jump straight into MobiFlight. Everything you need is right there. But let's start with FCU test. We want to go into this directory here. We want to download all of these files here. So what we're going to do is, just to save some time, we're just going to quickly go to the download this folder here. We don't want to download the whole directory, so we've downloaded everything we need there. Okay, so you'll have that downloaded, and we just want to rip that right out here. So we've got these files here. So now what we want to do, this is just raw plug and play. So we've got our files. Let's have a closer look at the device now. So what I want to do is just talk through the device here. When it comes to you, it will be in very similar packaging to this, but it'll probably have some artwork on it. I'm just waiting for that to actually be shipped out as well at the moment. But here is here's one I made earlier, as they say. So the device comes in the nice packaging like that. So we're just going to pull this out here, and we will. We'll just get rid of the box for now. Now the device does not come pre-soldered with the pin headers on, but so I have soldered these on myself. But it's just 5 pin headers there. That's all we need. Then we'll put the device just at the back there for now. And the next thing we're obviously going to need is an Arduino. Now I'm just using the Mega here because this is what we use for MobiFlight. But for this program, if you should get the Mega because you're going to need it for MobiFlight. But if you want to just quickly test it, this program that I've written will work with like an Arduino Uno or something like that. Just need to make sure you've got the pin numbers around the right way when you change it. But ultimately, we've just got this Arduino Mega here. We're going to get this up and running. Now, this device has 5 pins, as I've explained before. Okay, so now we've got our Arduino and now we've got our device here. All we need to do is just connect this up. It's just simple 5 pins. So on the, if you want to choose it out of the box, you need the 13, 12 and 8 pin for 3 wires. There will be a CS clock and data. And then on the, we need to connect a plus 5 volts. It must be a 5 volt supply. So if you've got a device that uses 3.3 volts, it won't be powerful enough. And then go into the ground there as well. So these just get connected up. The 13 goes to the chip select or the CS. 12 goes to the clock and 8 goes to the data. I just slip on there like that. Okay, so now we've got the device connected. That's the simple way of connecting it up. Next thing we're going to do is connect up to USB. Okay, so now we're back in the PC. We're going to go back to the file we downloaded earlier. So we had these files downloaded. We just need to rename this folder just by deleting this here, just to FCU_test, all caps. That's because that's the name of this Arduino file here, and when you use Arduino, it must have the same file name. If you've not used Arduino before, I'd recommend it. It's really easy to use, friendly, and if you just want to get up and running and playing around with this, it's the perfect tool. You can do this in any other IDE if you so wish. But here is what the project looks like. If you want to just get up and running, you don't even have to worry about any of this. It's all done for you. You can just connect it and away you go. But if you want to play around with this, then you can. But the first thing we need to do is just select our board that we connected here, which is our Mega. Okay, the other thing we can notice here is that we've got the other files that are in that folder are listed up here, and these are our libraries. So these are the two that we've written for you, and then these are the driver chips for the driver libraries for the chip on the back of the PCB. You don't need to worry about those two at all. They just have to be there for the thing to work. But these two here, if you want to get into them and find out how they work, then you can. But ultimately, this is all you need. You just open up that INO file, and it will all be done for you. You've selected the Arduino Mega. Make sure that you've got it the port selected here. Yours would be a different number. It just really depends on your system profile, but just make sure that you've got a COM port selected for the Arduino. If you're using a different device and you have to change the pin numbers, here's where you do it here. So the CS, the clock, and the data pin, you can change those pin numbers to whatever you want. The other two, which are ground and power, will obviously just be ground and power, so you can't change those. But if you need to use different pins, you just change these numbers here. Otherwise, you just click this upload button here. And you will notice that you'll get some flashing lights on the Arduino itself, and then once you get this message here, done uploading, we can just compiling and uploading is done. We know now that this program is on the actual LCD. Now I'm going to turn the lights off in this photo booth. Okay, I've just turned the lights in the photo booth off just because I'm using a DSLR camera and it's not very good. You probably see some slight strobing on there. That's not on the display. It's just because this camera is a DSLR camera. Probably not the best choice for filming this, but you get the point. So now we can see that it's just cycling through some pre-programmed display functions. And that's it. It's obviously not connected to a flight simulator at the moment, but we can see how the device looks, how it performs, and what's going on with all the different display options as well. So let's have a look at this code a little bit. Let's just talk through what's going on here. I'll just quickly get rid of that there for a minute. So the first thing we're doing is we're just going to say, let's use the library that I've written, which is this file here. Don't worry about it, it's all there, but I'm just saying let's use that library. Then we're going to say what pins we're using to be connected to it. So here we've created the object. So we're saying we want to create an object of this type, which is of my library here. We're going to call it FCU, and we're going to set it up with the clock, the chip select, the clock, and the data pin as well. Then we have this thing here called void setup. This is a function that will run just once on the Arduino. If you're not familiar with sort of how Arduinos work, they will always call this setup function once, and once that's done, it will run this loop function forever while the device is alive. So what we want to do is we want to call this attach function here on our FCU device, which we created here. Again, we're just passing through the chip select, clock, and data pins to it. That will set up the device. It will basically turn on the alt level change symbols, all the startup stuff that's always going to be there. It will fire up the chip on the PCB and configure it ready for the LCD configuration that it needs. Then it will run this loop function here. Now, this is just a workaround where we're using this as like a manual device here. You don't need to do this, but just because at the end of the function I'm clearing the whole LCD, it will clear the setup that happens during the attach. So the setup will always be there when you're using it. It's done, but just for this loop, I'm calling this here, but that's basically just setting the start labels every time the loop runs. So then we have the first state here, which is the one displaying 5,000. and then the dots and dashes everywhere else. So we just say, right, we want to toggle the track and heading mode. If we pass it the parameter 0, we'll get a heading mode. If we pass it 1, we'll get track mode, and that will change obviously the heading and track mode there on above the heading number display, and obviously the track FPA as well. That does all that for you as a singular function. And then we have this set speed mode. So obviously we have two types. We've got speed and mark, or Mac, whichever way you want to pronounce it. I can never get it right. So we then say, right, we're going to set speed mode, and then we pass it the display, the value that we want to be displayed. Here we're just passing the value 0 because we're going to be putting dots and dashes, but we want it to be in speed mode. So you could pass that any number really, or any valid number, which is obviously a number that can be displayed. And then, yeah, we'll just pass it 0 because it doesn't matter, because we're going to overwrite it. And then we want to set the dashes in the speed, and we want to set the dot as well next to that as well. So the 1 means true. If we put 0 there, it will set them to false, basically. So 0 is false and 1 is true, and that will, with the 1 in there, set those alive. And then we want to do the same for heading, with the dashes and the dot. We want to set those to true. Obviously the heading mode is being handled up here, so we don't need to do anything else. Then we want to show an altitude value of 5,000 feet, which is what it does. It will display 5,000 for us. And then we want to set the vertical speed section to the dashes. We want to set that to true. So that will give us a display of 5,000 feet, and then dots and dashes across speed, heading, and vertical speed as well, which is what we saw when it looped through. The next state here will give us the 12,000 feet and some other numbers here. But this is really where I want to show off the ability to do the plus and the negative number on the level change vertical speed, which is what is sort of the showpiece that I'm proud of, to have this plus symbol. So we set the speed and dashes, we set the speed, dashes and the dots to off or false by passing a 0 there. And we want to do the same for the heading, dashes and dot. We want to pass them to false by passing 0 there. And then the vertical speed dashes to false. So we've basically got rid of all the dashes and dots that were there. That's all that's doing there. So again, just demonstrating really how much control you have over each element. It may seem like, oh, it's a bit cumbersome to have to do, these things one after the other, but it's some developers may want that full control. So it's there if you need it, but you can then obviously automate some of these as well. You can write a little function that does all of these things together. But I didn't want to restrict people with that, so I wanted to make each part of the LCD as accessible as possible. So for this little demo state, it's a little bit cumbersome to have to do this, but if you want to just get going with MobiFlight, which I'll show you in the next video, a lot of this is all automated. You won't have to worry about any of this. You won't even have to worry about any of the code at all. But if you really are one of the developers who wants to get in, hopefully this flexibility here will give you that option to sort the logic out around your existing system, sort the logic around your existing system with as much ease as possible by having this detailed level of control. Then the mark mode, obviously with mark we have a 0 point and then a number. When we set mark, same with speed mode earlier up here, we've got this set speed mode. The diff opposite to that is obviously set mark mode. We pass the speed to it, so we could pass 200 for 200 knots. And then with mark mode, we don't want to pass in 0.80. We know that it's always going to be 0 point. So if we want the 80 after the 0 point, we just pass 80 with mark mode, and that will give us the display of 0.80. That's again, all of the logic behind that is all handled in this set mark mode function here, but hopefully just the ability to just pass the 80, that will change the speed label to mark, and add the 0 and the decimal point in. But again, that's why when you go back to speed mode, you want to set it to speed mode. Even if you want the dots and dashes, you want to set it to speed mode to get the speed label back and then get rid of the decimal point for the mark as well. So you've flip the two, and the same with mark. If you want to go into mark, then with no value, you would just pass 0 and you'll get 0.0. And then if you want to overwrite that with dots and dashes, it would. But it's, you have the ability to do things that would not normally occur as well. Then same as before, we just want to show a heading value. Sorry, not same as before. That was the altitude. So here we can just show a heading value to give us a heading value of 245. And then we can show the altitude value. Now with the vertical value, this is the only difference here. If we pass it a positive number, it will show us that plus symbol. The only time we will get the negative number is if we just have to pass it a negative number. So if we want a descent rate of 12,000 feet per minute, we would pass 1,200, sorry. That would be a bit terrifying, wouldn't it? 1,200 feet per minute, we would then pass in the negative symbol. But if we want to show a climb of 800 feet per minute, we would just pass in 800, and that will automatically give us that plus symbol. So again, you don't have to worry about cases of that. You're just passing the number here. And if it's a negative number or a positive number, it will display that appropriately for you as well. By the way, these delays here are just so that you can see the device, because the Arduino will loop through this code very, very quickly. So I'm just adding in 3000, which is 3-second delay, so we can just see what's going on. And it's not really relevant. It's not part of the thing here. It's just otherwise it would just very quickly go through all these. You wouldn't see what's going on. So that's all those are there. And then finally, we've got this last state here, which is just, again, setting the speed mode to 250 because we were in mark mode here. So we need to set speed mode to flip us back round. And we want to toggle the heading and track mode back now. So we want to go into track mode, because before it was just in heading mode, and you can see that wasn't changed in the last one. So during here, we were still in heading mode. So now we want to go, we actually want to go to track FPA mode here. So we'll just pass it a 1, which is here. Then we want to show a heading value of 210 and then an altitude value of 16,000, and we can show here an FPA value. So we're in track FPA, so instead of showing a vertical value, we want to show a FPA value, which will give us, if we want of 3 degrees, we will pass in 30. The decimal is handled automatically, so we don't want to pass in 3.0 or just 3. We want to pass in 30, and that will give us the 3.0. So it is slightly different to the mark mode. It's something you've got to be careful of. If the decimal, for the mark mode, we don't worry about the decimal point, or rather we only give it what's after the decimal point. But because here the decimal point, we could put a number either side of it, i.e. we could put 3.2. We're not always going to have a number before. Here we have to put in the appropriate number. And again, if we wanted to show a positive, we would just remove this negative symbol here, and that would give us 3.0. The other thing I forgot to mention as well is the vertical value, where we're showing 12,000 here. Hopefully you should have noticed as well, which I'll show you again in a minute, the zeros are displayed correctly on the LCD as well. They're not full zeros, they're the small square zeros at the bottom. So if I bring back the display here, we'll be able to sort of talk through the things that we've just pointed out here. So we'll wait for the cycle to come back round. Here, so we've got the dots and dashes and the 5,000 feet that we spoke about. We've got the 12,000 feet with a negative 1,200 and the small zeros, and then the plus symbol with the small zeros. And then we've got minus 3.0 for the FPA, and we can see the heading and track modes changing around there as well. So it goes quite quickly. So again, minus 1200, and there's the plus symbol. And then we've got the FPA track mode with minus 3 degrees, and then the 5000 around as well. So now what happens if we change some of this code? So let's do exactly that. Let's get a positive on the FPA, and we will say we want to go up by 1.5 degrees. So we're just going to pass in 15, and that's 1.5. We don't pass it with the decimal number there at all. And let's set the mark mode again to, let's do something a little bit different. Let's do 7.5. And let's do, let's do that for now. So I've made those changes. I'm just going to save the file, and then all I have to do is just press upload, and we will see, hopefully there, now the program is uploaded. We should see those changes. So mark 0.75 as expected, and then plus 1.5 on the FPA there as well. So you can see it's simple as that. All of the automation is handled behind the scenes by the library. And then after that's done, we just clear the LCD, wait just a short amount of time, and then go back to begin the loop, and we just keep going round. You could add in as many different things. You can play around with this as much as you want, and if you want to just get a quick overview of what functions are available, there's two ways you can do it. If you look at the header file, here will give you a list of basically just every function that is available to you. So we can see some setup stuff here. Don't worry too much about that. But in terms of the functions that you can play with, we've got some speed and mark functions here. So we can set the speed label, set the mark label. You can do that manually if you really want. We can set the speed dot and the speed value. Here really is the one we want, show speed value. You can play around with that. And then you've got some heading, track and latitude functions, altitude and vertical. So we've got some functions for each part of the LCD. But just to make things easier, you can get in and use these preset states as well. So the set speed mode, as I said, will handle a lot of these changes for you. The mark mode will handle a lot of those changes for you. Set heading mode. So these are probably really where you want to be playing around with. But if you want to really get in and just do some deep diving manual control over different things, so just turning that speed label on and off, you can do that if you want. If you want to do it as part of this function, it will do it all for you. Then if you really want to get deep diving into this, you can go in and see all this is all how it's actually being done, and then there's a little bit here about how MobiFlight will interact with, but I'll go more into that in the next video. But ultimately these are the only functions that will MobiFlight will use. So you can see you can control the whole device with just these functions here really. But yeah, I encourage you, if you're into this sort of thing, go in and have a play with it. This in here, you can't do anything really wrong here. Just don't pass more than 5 volts through to it from the Arduino and you'll be fine. None of this code is really going to break it. And again, if you put some dodgy code through, just go back to this original one. You can re-download it and just flash it back through to the device, and you can start from the beginning. But really getting in here, playing around with this, and just seeing how this device works, I think will give you some excitement once you get this brand new out of the box. And sometimes as well, if you're trying to integrate this into an LCD and you just want to see how things are working and looking, you obviously don't want to have your flight simulator running or whatever, you can just put this simple program on there, and you can just have this on your desk and you can just see it changing round. And as you hold it up to a panel, and you're trying to make things fit and work, and you just want to test it out, there's a nice little program to do that as well. But yeah, so really that's the short version of just getting this device out of the box, up and running, and how to play with the code here. So yeah, please do that. If you have any questions, do contact us, but really hopefully there shouldn't be too many. Everything should be pre-answered in there, and I'm going to do another video again detailing the MobiFlight setup as well. So yeah, thanks for watching this video. Hopefully it's been useful for you. I look forward to seeing this in your designs in the future. So thanks very much for watching again, and I will talk to you soon. Bye bye.